Hey there, and welcome. Today, we're putting on our detective hats to solve some of the chemical mysteries that are hidden all around us in plain sight. We're going to dive into the chemistry that explains so much of our daily lives. So let's get right into it.
Think about it for a second. Why does a tiny bee sting burn like crazy? And how on earth does a little tablet just magically fix an upset stomach? Well, I'm going to let you in on a secret. It's not magic. It's chemistry, and we're about to crack the code.
And the master key that unlocks all of these mysteries? It's a simple two-letter code, pH. This little measurement is the secret language behind everything from our own digestion to the health of the entire planet. Understanding it is step one. So let's start right there by cracking this code. Our first mission is to really get a handle on the main tool for our investigation, the pH scale itself.
Okay, check this out. This is our chemical roadmap, the pH scale. It's super simple. It just runs from 0 to 14. Anything with a pH below 7 is an acid, anything above 7 is a base, and right there in the middle at exactly 7, that's neutral. Easy, right? So, to recap real quick, acids are below 7, bases are above 7, and neutral is right on the money at 7. That's it. It's such a powerful way to categorize pretty much everything in the chemical world around us. And this is where it gets really cool, when you see how many everyday things fit on this scale. Just look, the acid in your stomach is way down there at a pH of about 1.2. That's super acidic. Lemon juice, also an acid, is around 2.2. Then on the other side, you've got bases, like milk of magnesia at a 10, and really strong stuff like sodium hydroxide all the way at a perfect 14. All right, so now that we've got our trusty pH scale, let's circle back and actually solve some of those mysteries we talked about at the beginning. It's time to see this stuff in action. First up, the case of the upset stomach. See, our stomachs use incredibly strong hydrochloric acid to digest food. But sometimes they make a little too much acid, and that's what causes that awful heartburn. So what's an antacid? It's just a mild base. Its whole job is to go in there and neutralize that extra acid, bringing your stomach's pH back to a happier place. Case closed. Now, here is a number I really want you to remember, 5.5. This number is the absolute critical tipping point when it comes to keeping your teeth healthy. You see, when the pH inside your mouth dips below 5.5, the acid that bacteria produce starts to literally eat away at your tooth enamel. And that's exactly why we use toothpaste. Most toothpastes are slightly basic. They work by, you guessed it, neutralizing those acids in your mouth to keep your teeth safe. And you know, the power of pH goes way beyond just our bodies. It affects the whole environment. Even rain has a pH. And when pollution in the air causes that pH to drop below 5.6, we get what's called acid rain. This can be absolutely devastating for life in rivers and lakes. And hey, it's not just humans who have figured this out. Nature has been using acids and bases as a tool for millions of years, especially for self-defense. And here we are, back to our very first mystery, the dreaded bee sting. A bee injects an acid, methanoic acid to be exact, and that's what causes all that pain and irritation. So what's the classic home remedy? Baking soda. Why? Because baking soda is a mild base. Just like the antacid in your stomach, it neutralizes the acid from the sting and helps calm it down. And it's not just bees. The stinging nettle plant uses that very same acid to defend itself. But here's the amazing part. Nature often provides the solution right nearby. The dock plant, which you can usually find growing right next to nettles, contains a substance that can help soothe the sting. It's like a built-in balancing act. Okay, so we've seen acids and bases neutralize each other again and again. But what's actually happening in that moment? What does neutralize really mean? Well, this is where our story takes a fun little plot twist. This chemical handshake has a name. It's called a neutralization reaction. When an acid and a base react, they don't just cancel each other out and disappear. No, they actually transform into two brand new things. And what are those two things? Well, one is water, and the other is something called a salt. That's right, every single time an acid and a base get together, they create a salt. Now, I know what you're thinking. Salt? Like the stuff I put on my food? And yep, you are 100% right. Common table salt, or sodium chloride, is the most famous example. It's what you get when a really strong acid,
hydrochloric acid, reacts with a really strong base, sodium hydroxide. But the story of common salt is so much bigger than just your dinner table. In fact, that's just the tip of the iceberg. This simple chemical is actually one of the most important building blocks in the entire chemical industry. Okay, so this might look a little intense, but the big idea here is actually pretty simple. This is called the Chlor-alkali process. You basically just take regular old salt water, or brine as chemists call it, and you run electricity through it. And that simple act breaks the salt water down into some of the most useful chemicals you can imagine. Seriously, just from that salt water, we get these 3 industrial giants. First, sodium hydroxide, that's used for making soap, paper, all sorts of things. Second, we get chlorine gas, which is absolutely essential for keeping our drinking water clean and for making plastics like PVC. And third, we get hydrogen gas, a clean fuel, all from salt water. And the list just keeps going. Common salt is the starting ingredient for bleaching powder, for the baking soda that we use in our kitchens, and even in fire extinguishers, and for washing soda, which is a super powerful cleaning agent. It's just incredible how much we rely on this one simple salt. So you see how it all connects? We started with a tiny bee sting, and that thread led us all the way to our healths, our food, and these massive industrial processes. The chemistry of acids, bases, and salts is truly all around us, shaping our world in ways we almost never notice. It really makes you wonder, doesn't it? What other mysteries in your daily life could be solved with a little bit of chemistry? If you want to keep exploring questions just like this, make sure you subscribe to the A1 Institute YouTube channel for more science explainers. Thanks so much for joining me.